Hi students, good morning. Today I am going to explain about new chapter. Chapter name is nitrogen family or 15th A group elements. Actually, some of the students they are requesting me, sir, we want to that chapter. So that's why I am prepared this chapter. Of course, I am not getting proper time to upload the videos. However, I am ready to give that uh, concept each and every chapter and constructive manner with detailed information. Really, I promise you, I must complete the chapters as early as possible up to May month. Okay, friends. God bless you. Thank you, my dear students. So today we are discussing about the chapter. Its name is nitrogen family. Okay, students. Nitrogen family. So actually, nitrogen family, periodic table. Now p block elements are started from that okay, 13th a group elements to 18th a group elements, like that. Okay, so here so that means here I'm ready to explain about the chapter. So our chapter name is picogens or maybe nicogens. Okay, now here the 15th a group elements, okay, are group 15 elements. So this is our chapter, group 15 elements. Okay, students, group 15 elements. Okay, so this is our chapter name. And now this group elements, that means 15th a group elements, consisting of these elements: nitrogen, phosphorus, arsenic, stibbium, and bismuth. And now recently added element is mescovium. Okay, students, mescovium. So these are the 15th A group elements. Okay, these are the 15th A group elements. And nitrogen atomic number 7, and phosphorus atomic number 15, and arsenic atomic number 33, and stibbium atomic number 51. Okay, students, and bismuth 83, and its atomic number is 115. Okay, so these are the elements and its atomic numbers: nitrogen, phosphorus, arsenic, stibbium, bismuth, mescovium. Okay ना. Okay, नाना पटेकर ऐश्वर्या सब मिलके, ओके, बिस्मत गया. नाना पटेकर ऐश्वर्या सब मिलके बिस्मत गया. Okay, so the last element name is mescovium. Once again, nitrogen, phosphorus, arsenic, stibbium, bismuth, and mescovium. Okay, these elements are collectively known as. Now the 15th A group elements are these elements. Now here these elements are collectively known as these elements are collectively known as nicogens. Okay, nicogens, nicogens, and their compounds are called, and their compounds and their compounds are called and their compounds are called as niconides. PNICO NIDS, niconides. Okay, students, once again, now the 15th A group elements: nitrogen, phosphorus, arsenic, stibbium, bismuth, mescovium. So these elements are collectively known as picogens, okay, or nicogens. Its name is the P is the silent term, okay, silent, okay, alphabet. So this name is the nicogens, and their compounds are called as niconides. Okay, their compounds are called as niconides. So actually, now these based on that properties, that means the arrangement of these elements, generally in the periodic table, the elements are arranged in that metals, metalloids, and next the sorry, now here non-metal elements and metalloids, and next to the metal elements. Okay, so actually these are classified into the top. Okay, now the first and second element, that means nitrogen and phosphorus, okay na, these two elements are simply non-metal elements, okay na. So these are the simply non-metal elements. So you have to take that nitrogen, phosphorus, and next in the arsenic and stibbium, okay. Now these elements are called as metalloids, okay students. So these are called as metalloids. What about last one? According to our printing books, that means now the bismuth, okay, bismuth. So this one is the typical metal element, okay. Now this one is the typical metal element, okay, typical metal element. So in this case you have to remember one thing. Now that is metallic properties, basically that means metallic properties gradually increase from top to bottom in a group, okay. Metallic character increases from top to bottom, generally increase or gradually increase. So once again you have to take that so this is the nitrogen element, phosphorus element, arsenic element, and stibbium element. Last one is the bismuth, okay. Now this is our latest element, okay, mescovium element. But up to here, so it's not included in our periodic table, that means in our recent periodic table. But however, okay now, so nitrogen, phosphorus, arsenic, stibbium, bismuth. So from top to bottom in the periodic table, okay, from top to bottom in the periodic table, what happens here? Metallic character increase, okay, metallic character increase. So you know already first and second two elements, okay, first and second, that means first element and second element. So these two elements are the non-metal elements, okay, non-metal elements. And arsenic and stibbium, okay. Now here listen friends, arsenic and stibbium element are that but that means these two elements are that metalloids. Now you know the metalloids means they behaves as the metallic property as well as the top non-metallic property, okay. And last element are, it may be these two elements are that typical metal elements, okay. So these are the typical metal elements like that one, okay. So these are the things about this one, okay. And here basically now the 50A group elements are that actually if the metallic character, if you have to check the metallic character in fourth A group elements and next in the fifth A group element, okay. If you have to compare the metallic character in case of fourth A group elements and next the fifth A group elements, now basically we in a periods from, that means the if you move from that across the periods from right left to right side, okay, left to right hand side. So then what happens here? 15th A group elements are less metallic in nature than that of 14th A group elements. Okay. If you have to check the metallic property within the group, metallic property increase from top to bottom in a group. But in a periodic table from left to right, metallic character, what happens here? It decreases. So that means now the non-metallic property should be increased when we are crossing the periodic table from left to right hand side, okay students. So this is the phenomena, that means these are the properties or these are the information about that metallic character next to the non-metallic character in case of okay, 15th A group elements are nicogen family, okay, nicogen family. And next one is the occurrence of that 15th A group elements, okay students. Occurrence of the 15th A group elements. Now the in case of occurrence, okay students, in case of occurrence, so this one is the OCCURANC. Okay, now occurrence of that 15th A group elements. Now actually now that means nitrogen. Okay, nitrogen element always occurs as a molecular state. Nitrogen molecule. Okay, it occurs as a molecular state. It comprises how much amount here? 78 percentage by mass in okay, 78 percentage by volume in Earth. That means atmosphere. Okay, that means now actually nitrogen element which is comprises which is available, okay na, that means in that atmosphere, that means in the earth atmospheric, okay na, that means in that universe it has that by volume is that 78 percentage by volume should be the available in that earth crust, that means in the universe only, okay na, this is the thing. And actually nitrogen is that okay na, 33, actually not a first second element, okay now this is the 33rd, that means 33rd, okay now most abundant element, okay now this one is the so 33 most abundant element, okay now students, so this is the 33 most abundant element in that universe, okay now? So this is the thing actually, okay now most abundant element in that one, okay, most abundant element in the case of okay nitrogen actually, okay. And next one is the now here the nitrogen occurs as that okay, nitrates. Actually the nitrogen elements occurs as that different nitrates, okay. nitrogen element Nitrogen element occurs in nitrates like okay, chili salt petre, and next in the Indian salt petre, okay. Nitrogen elements occurs in the form of nitrates actually, okay. Nitrogen elements occurs in the form of a nitrogen elements. So first one is the first formula is okay, what about this one here? Chili salt petre, PETRA, okay, that means now that is the NaNO3 compound, okay, na? Chili salt petre, NaNO3 compound. And one more thing is the second one is okay na, so that is Indian, okay students, Indian salt petre, okay, Indian salt petre. Now that is the KNO3 compound, okay now KNO3 compound. So that is potassium nitrate compound actually, okay, that is the potassium nitrate compound. Now here first one is what about the first one here? First one is the okay, chili salt petre. Nitrogen element occurs in the form of a nitrates. Okay, in the form of a nitrates. Like first one is chili salt petre, NaNO3 compound, and the second one is the Indian salt petre. So that is the KNO3 compound, potassium nitrate compound. Okay, students. And actually, not only these compounds in the each and every element. That means if you go for if you talk about that what about that one here? If you are talking about that phosphorus element, if you are talking about that okay, an arsenic element and stibin, so they are obtained in the form of various minerals. Okay, they are obtained in the form of various minerals like so like nitrogen. Okay, so nitrogen is obtained as in the form of nitrates like chili salt petre, sodium nitrate, and Indian salt petre, potassium nitrate, KNO3, like that. Okay. Now here phosphorus element also occurs in the form of different elements. And one more thing here, listen. Now before going to phosphorus elements, nitrogen may occurs in the proteins. Okay, and it may present in that animal that means living things. Okay, animal beings, or it may be animal living things. Okay, and next one is the potassium, sorry, not potassium, phosphorus now, so sorry. Now that means phosphorus element which occurs in the form of different minerals like apatite families, okay na, apatite, APATAT, okay na, apatite families, okay na. Now the phosphorus element which is occurs in the form of a different families like minerals of apatite, okay na, minerals of apatite. So actually what is the formula for the apatite here? Now like this one, okay, now that means here this is the Ca, calcium 9, okay, calcium 9, and this one is the PO4 taken 6 times, and Ca, okay, now this one is the X2 type compound, okay, na, Ca X2 type compounds. So this is the Actually it is the minerals of that phosphorus. Okay, now minerals of that phosphorus. Now the phosphorus element is occur in that different apatite families. Okay, now like now here apatite family means the apatite family, the composition of the apatite family, now that is calcium 9 atoms. Okay, now PO4 taken 6 times, CaX2 type of mole. Okay, now CaX2. Now here X is equal to I think fluorine may be present. I think chlorine may be present, and next one is the OH group also present. Okay, now fluoroapatite next in the hydroxyapatite compound. Okay, now here fluoroapatite compound. And now here, so this one is the FLUO. Okay, flora apatite. Okay, flora apatite families. Okay, fluoroapatite families. Now here calcium 9 atoms, and next one the PO4 taken 6 times, and CaF2 compound. Okay, Ca9 PO4 taken 6 times and CaF2. So this is the fluoroapatite compounds. Okay, fluoroapatite compounds. And what about the next one here? Chloroapatite. Okay, chloroapatite. So that one is calcium 9 atoms. Okay, and phosphorus 6 atoms, and CaCl2 molecule. Okay, so this is the chloroapatite families. Okay, chloroapatite family. And what about the last one here? Hydroxyapatite. Okay, hydroxyapatite. Once again, listen please. Listen please. Okay, hydroxyapatite. Okay, now this one is the hydroxy apatite. Okay, apatite. So here calcium 9 atoms. Okay, next one the phosphorus same 6 times. So, and next one the CaOH taken 2 times. Okay, CaOH taken 2 times. So this is the so these are the source or minerals of that phosphorus elements. Okay, minerals of that phosphorus elements. So not only for the, that means now in that fifth A group elements. So the nitrogen having that okay, some what about the first one here? Chili salt petre sodium, that means NaNO3 compound. And one of the important mineral for that nitrogen is Indian salt petre. Okay, potassium nitrate. If you are going into the top, okay, phosphorus elements. Okay, now the phosphorus element also obtained in the form of different okay, apatite families. Okay, that means the apatite group, the apatite molecule of the phosphorus is calcium 9 atoms. Okay, okay, PO4 taken 6 times, and CaX2 type of molecule. Okay, Ca9 PO4 taken 6 times, and CaX2 type of molecules. Okay, now these are having that that means if the X may be chlorine atom, if the X may be fluorine atom, if the X may be OH group. Okay, based on that these groups may be classified into different types. Now that is the fluoroapatite family, chloroapatite family, and hydroxyapatite family. Okay, now hydroxyapatite families. And next one is the now the remaining element, that means arsenic, strontium, bismuth also found in their okay, different minerals. Okay, that means in their different minerals of that compounds. Okay, that means especially that means okay. Okay, now these are the you know already. Okay, now phosphorus is over now. Arsenic, strontium, bismuth now. Okay, that means arsenic element and strontium element, bismuth element. Okay, now these are present in the form of a okay, sulfide ores. Okay, in the form of a sulfide ores. Okay, in the form of a sulfide ores. Arsenic, strontium, bismuth. Okay, now these are obtained in the form of a sulfide ores. Okay, now students, sulfide ores. Now this is the occurrence about that fifth A group elements. Okay, fifth A group elements, friends. And next one is the what is the general electronic configuration for that fifth A group elements? Okay, what is the general electronic configuration for that fifth A group elements? So just now we saw these things only. Okay, now just now we know about this one. Okay, once again, nitrogen, phosphorus, okay, arsenic, and strontium and bismuth, and next to the mescovium. Okay, so I think it is started in the top. First period means hydrogen and okay, hydrogen, helium, and lithium is the second period. So this is the third period. Okay, I think here it is started from the so n is equal to 3, Okay, na n is equal to fourth period. Okay, I think it is right or wrong. We will check it here. We will check. Okay, na now here that means n is equal to fourth. Okay, na n is equal to, okay, here, okay, um, hydrogen helium first period, lithium to, okay, na, so sorry, now lithium to, so it is also come same second period element, and here this one a third period, fourth period, fifth period, and here sixth period, and next the n is equal to seventh period elements. Okay, now you know that means actually 2s2 2p3 configuration. Okay, now here 3s2 3p3 configuration, is it now 4s2 4p3 configuration. Okay, 5s2 5p3 configuration. Okay, 6s2 6p3 configuration, and next the what about this one here, 7s2, and next the 7p3 configuration. Okay, 7p3 configuration. So generally, what is the general electronic configuration for that seventh A group elements? Okay, students. Now you have to write it. So that means general electronic configuration is NS2 NP3 configuration. Okay, NS2 NP3 configuration. So simply here you have to check about these things. NS2 means S orbital is completely filled. Okay, now it is the completely filled orbital. Okay, S orbital is completely filled. S orbital is okay, so here S orbital, okay, S orbital is completely filled. Is it right now? S orbital is completely filled. What about P orbital here? P orbital also having the 3 electrons. So that means it is also same thing of filled orbital. Is it right now? Of filled orbital. Okay, now students, of filled orbital. So this is the general electronic configuration for that fifth A group elements. Okay, fifth A group elements. You know, NS2 NP3 is the general electronic configuration for the fifth A group elements. S orbital having the completely filled electrons, and P orbital having that, okay, now off filled electrons. Okay, now off filled electrons. So S orbital means like this one, it's completely filled, and P orbital means okay, like this one. So each and every orbital having, okay, now that means one electron in that each orbital. So that's why it is the off filled configuration. Okay, it get that off filled configuration. So that's why it give that extra stability for that group elements. Okay, it get that extra stability for that group elements. Okay, so this is the thing about that electronic configuration. Okay, students, electronic configuration. And next one I want to discuss about that okay, atomic and next the ionic radius of this compound. Okay, generally, okay, now here covalent or it may be atomic radius. Okay, now generally here we want to discuss about that covalent or atomic radius. Okay, students, covalent or atomic radius. So here that is the I want right here. So this one is atomic radii. Okay, so this one is the atomic radii. So basically now that means covalent radius. Okay, covalent radius or it may be what about this one here, ionic radius. Okay, students, ionic radius increases basically. Okay, covalent radius or ionic radius increases down the group. Is it clear now? Down the group. So what happens here, if you are moving, if we are moving from the top to bottom in a groups. Okay, if we are moving from the top to bottom in a groups. Okay, then what happens here, I think okay, so this is the atomic radius. Wait, okay, covalent radius. Okay, covalent radius or ionic radius increases down the group. So how do you understand this thing here? So for example, you should take the nitrogen element. Okay, phosphorus element, next the arsenic element, and strontium, and next the bismuth, and next the mescovium element. Okay, students, so for our understanding purpose, I have to write that structures for this. Okay, nitrogen size. Okay, and slightly increase the phosphorus size. Okay, and next the arsenic size. Okay, next one the strontium size. Okay, students, next one the bismuth size, like that. Okay, and this is the higher than the top. Okay, mescovium. Okay, then what happens here, size of the nitrogen, size of the phosphorus, size of the arsenic, size of the strontium, size of the bismuth, and the size of the mescovium. So in a group, from top to bottom in the 15th A group elements, size increases. Okay, now atomic size increase. That means covalent size also. Okay, now that is also increase. Okay, now but here actually what happens here? Now the size increment is up to, okay, nitrogen to phosphorus. Okay, now covalent size is increment is a considerable increment. Okay, now considerable increment in that from nitrogen to phosphorus. Then what happens here? Here arsenic to bismuth. Okay, so it is not a sharp increment. Okay, it's not a sharp increment. So very small increment. That means small increment size is there. Okay, that means this is the considerable. Okay, okay, now this one is considerable. Okay, now so considerable size increment. So from only nitrogen to, we have to observe that considerable increase of the size from the nitrogen to phosphorus is possible. So then after size not increase in that much of sharp range. Okay, that much of sharp range. Okay, what is the reason here? Due to, okay, now completely filled d orbitals, or it may be f orbitals. Okay, now only one reason is there. Okay, now only one reason is there. So actually atomic radius of that 15th A group elements, atomic radius of that okay, nitrogen family. So here nitrogen element to phosphorus elements, we have to observe that considerable size increment. Then after we should not get that. That means we should not observe the sharp increment of the size. That means due to okay, na completely filled d or f orbital. Okay, na only one reason is there. So that is the due to completely filled in that d and f orbital. Okay, na, and one more thing is the nuclear effect also. Okay, na nuclear effect also considerable change. Okay, na considerable size. So you have to remember that thing also. Okay, na. So only one thing is them due to, okay, that means completely filled orbitals of d and f orbitals in this case. Okay, na d and f orbitals in these things, like that one. And next one, okay, what about the next one here? Atomic radius of 15th year group elements. Okay, students. Okay, na. So here atomic radius. Okay, students, atomic radius of okay, now that is 15th group elements. Okay, atomic radius of 15th group elements are lesser than that of atomic radius of 14th group elements, students. Okay, and now that is the 14th group elements. Okay, students, 14th group elements. Atomic radius of 15th group elements are lesser than the top atomic radius of 14th group elements. Okay, so what is the reason? What happens here? If you are moving from that left to right, then what happens here, students? So left to right, so size decreases. Okay, size decreases. And one more thing is the nuclear. Okay, and nuclear effect is nuclear effect is increases. Okay, nuclear effect is increases. So actually here nuclear effect increase, as well as the number of electrons also added within the same cell. Okay, as well as, now here you have to write one more statement, as well as, okay, as well as number of electrons also, number of electrons also added within same group. Okay, that means within the same, okay, within the same group, or it may be same cell, like this. So that's why nuclear effect. Okay, that means nuclear effect increases. So that's why so simple thing is the covalent radius decreases, students. Okay, na covalent radius decreases. So only one thing is there, nuclear effect is increases. And one more thing is the now the newly added, that means the electrons which are added into the top of same orbitals. So that's why here the size of the elements may be, okay, now here that is the size of the element. Okay, now should be okay, now remains constant, or it may be decreased, like this. Okay, students, remains constant, or it will be decreased, like this. Okay, so this is the phenomenon. Next one we'll discuss about the next concept. Now that is ionization enthalpy. Is it clear, students? Ionization enthalpy. Now here we want to discuss about the next concept. Now that is ionization enthalpy. Okay, now ionization enthalpy. So get ready, please. Don't feel boring. Actually, so these are the basic things, and actually these total things are learned in that. That means we have learned in that. So periodic table only. That's better for us. Okay, so actually ionization enthalpy. Okay, now students, ionization enthalpy. First of all, we want to discuss about the ionization property, ionization enthalpy property within the group. Then after completion of that ionization enthalpy property within this 15th A group elements, then after we have to compare that ionization enthalpy of that adjacent group like 14th A group elements like that. Okay. So you know you have that one concept. So size increase from top to bottom. Is it clear now? Okay. Now size increase. So here this one is the top to bottom. Okay, students, top to bottom. Then what happens here? Size increases. Okay, now top to bottom size increase. Is it clear? Is it clear now? Top to bottom size increase. So that means when the size increases, okay, so ionization enthalpy, okay, ionization enthalpy decreases, okay, ionization enthalpy decreases when size increases. Okay, now when size increases, so this is the phenomena. Okay, that means actually students, you have to write like this one: ionization enthalpy is always inversely proportional to the size. Is it clear now? Ionization enthalpy is always inversely proportional to the size. So that means I think size increases. Okay, ionization enthalpy decreases. Size decreases. Ionization enthalpy increase. Okay, this is the phenomenon. And one more thing is here. Actually, one more thing is there. Now that is the extra stability are there. Okay, now extra stability. That means now you have that P3 electrons. That means off-filled electron configuration. Okay, now so this one is the off-filled electronic configuration. Okay, students, off-filled electronic configuration. Okay, now off-filled electronic configuration. Okay, students, and if you have to compare that if you have to compare them, so ionization enthalpy of the 15th A group elements with 14th. Okay, actually I think you got it. Okay, now what I'm explaining here, ionization enthalpy. So ionization enthalpy means you know the definition. Minimum amount of energy is required to remove the electron from the outermost orbit of an atom which is present in the isolated gas state. Okay, so that is the ionization enthalpy phenomenon. But here we will study the ionization enthalpy phenomena in case of 15th A group elements. If you take the Na group, okay, if you discuss about the ionization enthalpy in the Na group, so when the size increase from top to bottom, so then ionization enthalpy size increase, ionization enthalpy decrease. Okay, size decrease, ionization enthalpy increase. So that means it is always inversely proportional to the size and ionization enthalpy like that. Okay, so this is the phenomenon. But here if you are compare that ionization enthalpy of, okay, 14th and next the 15th A group element. Okay, basically 15th A group elements having, okay, that means now here ionization enthalpy of 15th group elements. Okay, now 15th group elements having, okay, much greater than the top that ionization enthalpy of okay, now that is okay students, so this one is the 14th group elements. Okay, ionization enthalpy of 14th group elements. Please wait here. Please wait. So actually, I'm not getting cursor. Wait, students. So, okay, however, ionization enthalpy of 15th A group elements are much greater than the top ionization enthalpy of okay, this one is the 14th okay students, group elements. Is it right now? 14th group elements like that. This is the phenomenon. Now here successive ionization enthalpies in this group. Okay, now successive ionization enthalpies. So actually here successive ionization enthalpy, successive ionization enthalpy in this group, okay students, in this group, successive ionization enthalpy in this group is now that is first ionization enthalpy, is less than the top second ionization enthalpy which is less than the top third ionization enthalpy is less than the top fourth ionization enthalpy, and like this one. Okay, so this is the successive ionization enthalpy. Okay, now successive ionization enthalpy. So if you compare the within this group, so that means ionization enthalpy of fifth A group elements. Okay, students, ionization enthalpy of 15th A group elements. Nitrogen has a greater ionization enthalpy than the top of phosphorus, which has the greater ionization enthalpy than the top of arsenic. Okay, students. Okay, wait, it catches just now. Okay, up to here. Actually, I am waiting for cursor, but I am not getting. Just now it opened. But just now it opened. Okay, now here I will write ionization enthalpy of our group. So nitrogen is the greater ionization enthalpy than that of phosphorus, which is greater than that of arsenic. Okay, then nitrogen, phosphorus, arsenic, and strontium, and then bismuth, like this. Okay, now so this is the ionization enthalpy order of 15th A group element. Okay, students, ionization. Okay, now ionization. Okay, now ionization enthalpy of 15th A group. So this is the order for the ionization enthalpy of 15th A group elements. And next concept is our next concept is electronegativity character. Okay, now electronegativity character. So actually, if you have to take that okay, now this one is the electronegativity tendency. Okay, now electronegativity tendency. So here basically electronegativity is decrease within the group from top to bottom. Okay, now so this one is the okay, electronegativity is decreases within group. Okay, students, electronegativity is decreased within group. Okay, so due to what the reason here due to increasing the atomic size. Okay, what about this one here? Due to, okay, no, students, increasing the atomic size, due to increasing the atomic size. Okay, students, now one more thing is the electronegativity of okay, this one is the electronegativity of 14th group elements are greater than that of electronegativity of 15th group elements. Okay, students, 15th group elements. Electronegativity of 14th group elements. Okay, electronegativity of 14th group elements are greater than that of electronegativity of 15th group elements. It's clear, students. Okay, now so here if you are kind of writing the electronegativity order within the group. Okay, electronegativity order within the group. So actually here electronegativity order. Okay, na, so that means electronegativity order, I think nitrogen is greater electronegativity than the top of phosphorus, which is also greater electronegativity than the top of nitrogen, phosphorus, and next the arsenic, which is also greater than the top of strontium, is greater than the top of bismuth. Okay, so this is the electronegativity order. Okay, students, electronegativity order. Nitrogen has greater electronegativity than the top of phosphorus, which has greater electronegativity than the top of, okay, strontium, and next the bismuth. Okay, nitrogen, phosphorus. Okay, nitrogen has the greater electronegativity than the phosphorus. Phosphorus has the greater electronegativity than the arsenic. Arsenic has the greater electronegativity than the top of strontium, which has the greater electronegativity than the top of bismuth. Okay, students. And next one is the what about the next property here? Now next property is melting point and next in the boiling point order. Okay, students, melting point and next in the boiling point order. So actually melting point of nitrogen is less than the top phosphorus, which is less than the top. Okay, actually bismuth has the greater, okay, melting point than the top strontium, which is greater than the top okay, arsenic. Okay, students, so this is the melting point order. Okay, nitrogen is less melting point than the top phosphorus. Phosphorus is the lesser melting point than the top bismuth. Bismuth is the lesser melting point than that of stibbium. Stibbium is lesser melting point than that of arsenic. Okay, student. And next one is the boiling point order. Okay, students, boiling point order. So here, in case of boiling point order, okay, phosphorus is the lesser boiling point than nitrogen. Nitrogen is a lesser boiling point than arsenic, which is a lesser boiling point than bismuth, which is also lesser boiling point than the top of stibbium element. Okay, students, stibbium elements. So this is the concept here. And next concept is okay, atomicity concept. Okay, next one is the atomicity concept. So next concept is atomicity. Okay, students, now here we want to talk about that one, atomicity. Okay, ATOMICITO. You can atomicity, that means atomicity means number of atoms present in that within the molecule, so that is called as atomicity. Okay, students, so nitrogen is always existing in that diatomic gas. Okay, so that means a nitrogen element. Okay, so this one is the nitrogen element. Okay, now I want write here nitrogen, which is exist as diatomic molecule. Okay, diatomic molecular gas, diatomic molecular gas. So phosphorus is existing P4 atomicity. Okay, nitrogen phosphorus. Arsenic also existing as that AS4 atomicity. Okay, nitrogen phosphorus arsenic. And next one the stibbium also existing. Okay, okay, students. So that means SB4. So it is also discrete. Okay, tetrahedral units. Okay, DISCRET, discrete. Okay, students. Tetra HEDR, hydral units. Okay, now these are called as discrete tetrahedral or tetra, sorry, not tetrahedral, tetraatomic units. Okay, students, discrete tetraatomic atoms. Okay, now discrete tetraatomic molecules. And now once again I will write here discrete tetraatomic okay, tetraatomic molecules. Okay, now students, once again, so nitrogen element is exist as diatomic molecular gas. Phosphorus exists as a P4 molecule. Arsenic exists as okay, AS4 molecule. Stibbium exists as SB4 molecule. But Bi does not exist. Bi does not exist as Bi4. Okay, it's not possible. Okay, Bi does not exist as Bi4 molecule. Okay, Bi does not exist as Bi4 molecule like this. Okay, that will be clear, friends. I think so. It is the phenomenon up to here. Okay, I hope I want to see. Okay, students.